Now, we'll discuss the definition of a conditional equation, an identity, and a rational fraction. So, first, let's discuss what a conditional equation is. Basically, in an equation where two algebraic expressions are equal for particular values of the variable. Now, that may sound confusing, but let's just clear this up in an example. You have this linear equation, and once you solve this, you can find out that x is equal to 3 by 2, obviously, because to get x on the left hand side, you'll basically divide this 3 by this 2. And so the value of x is equal to 3 by 2. So 2x minus 3 is a conditional equation, and it is true only if the value of x is equal to 3 by 2. So if the value of x is equal to 3 by 2, the left hand side is equal to the right hand side, and that is the condition. So we have the second example. This is a quadratic equation. So obviously a quadratic equation will have two solutions, two values for the variable. So x will have two values over here, and once you solve this, you'll find out that the values for x become 2 and 3 minus 3, sorry. And basically this quadratic equation is a conditional equation, and it is true only for these two values of x. Now let's discuss what an identity is. It is an equation which holds good for all values of the variable. So basically you have this equation, and this equation is an identity, and its two sides are equal for all values of x. So if you basically plug in any value of x, the left hand side will be equal to the right hand side. So this is an identity. Similarly, you have over here this equation. Once you multiply this bracket and this bracket, the components basically that are inside the brackets, once you multiply them, you get this quadratic equation. So basically the left hand side and the right hand side will be true for all values of x. They will be equal for all values of x. So this is also an identity. Now let's see a rational fraction. Now we know that for example, this p by q, where p and q are integers, this z represents an integer. So p and q must be integers, and q must not be equal to 0, obviously, because that becomes an undefined result. So this p and q, for where p and q are all integers and q is not equal to 0, it is called a rational number. It is called a rational number. Similarly, if you have two polynomials, p of x and q of x, and so they are being divided, so p of x divided by q of x, and q of x must not be equal to 0, obviously, and it has no common factors. P of x and q of x have no common factors. So basically this is the what do you say, the simplified form. This will be called a rational fraction, not a rational number. This will be called a rational fraction because we're dealing with polynomials on the numerator and denominator.